Morning students, I hope you all are good. Today we are going to discuss lesson 4 Electromagnetic Induction and Alternating Current. In our previous class we have discussed so many topics. Am I correct? Today we are going to discuss a new topic, methods for producing induced EMF. What is that? Methods for producing induced EMF. What is our topic? Once again recall. See, methods for producing induced EMF. Actually, in our previous chapter, that means second lesson, current electricity, we are detailedly discussed EMF, isn't it? Today we are going to produce a different method producing induced EMF. Just I recall what is EMF. The expansion of EMF is electromotive force. What is that? Electromotive force. Am I correct? This electromagnetic force is the characteristics of any energy source capable of driving the electric charge around the circuit. EMF means electromotive force. It is the characteristics of any energy source. Any energy source capable of driving the, capable means ability to move that. What do we move? Even electric charge. So it is an energy. EMF is the energy source capable of driving the, what they driven? Electric charge. Where that means in a given circuit. In a given circuit. If any problem to understand this electromotive force, so electromotive force simply we call it EMF. It is the characteristics of what? Any energy source capable deriving the electric charge around the circuit. What is that? Around the circuit. In our previous chapter, lesson 2, we have already discussed electromotive force is not a force. EMF is not a force. We have to do some external work done to move. What is that? Work done to move. What we have to move means unit electric charge. Unit electric charge. Where to move? Around the circuit. Where you have to move? Around the circuit. Around the circuit. So EMF is not a force. See that EMF is not a force. We already detailed studied in our previous chapter. So no need to explain. I hope that. So what done to move? What we have to move means unit electric charge. Where we have to move? The circuit. Where means the electrical circuit. Okay, got it. So unit of EMF is nothing but joule per coulomb. Important one more question. See, I underlined that. What is the unit of electromotive force? Joule per coulomb. Repeated one more question. So please note it down. So this EMF is the energy source. No. What are the energy sources given the EMF? For example, electrochemical cell, solar cell, thermoelectric devices, thermoelectric device, electric generator are the sources produce the EMF. So source to produce EMF. What are the source to produce EMF? Generally they ask 2 mark down question. So electrochemical cell, solar cell, thermoelectric device, electric generator. Not only these few examples, many examples are there. In our syllabus they are given only this. So you have to refer the other textbook. You will get that what are the other devices. But in our exam point of view, no need. This is enough. I hope that. So today we are going to discuss what are the methods, different methods producing induced EMF. Actually, this is an introduction of induced EMF. Now to producing induced EMF, there is various methods are there. Today we are going to discuss what are the different methods producing induced EMF. Now this is okay, understand now. So EMF is nothing but electromotive force. So methods for producing induced EMF. There are 3 methods are there producing induced EMF. What are the 3 methods? First method, changing the magnetic field. Changing the what? Magnetic field. So that represented by V. Second method, changing the area of the coil. Changing the area of the coil. That represented by A. Next, changing the orientation of the coil. That represented by theta. So, what are the different methods producing induced EMF or methods for producing induced EMF? This is a repeated 2 mark question. So, first one, changing the magnetic field. Second one, changing the area of the coil. Third one, changing the orientation of the coil with respect to all time. So, what are that? Just I once again remember that changing the magnetic field, changing the area of the coil, changing the orientation of the coil. Changing the orientation of the coil. Now we are going to discuss one by one how the induced EMF produced when changing the magnetic induction, when changing the area of the coil, when changing the orientation of the coil. First we are going to discuss changing the magnetic field. See here in that 3 topics, the first one and last one very important, because the changing the magnetic field is based where that changing the magnetic field used means transformer. That transformer. And changing the orientation of the coil where they use means the electric generator. One last question, electric generator and electric motors. Electric motor. So changing the orientation of the coil is very important in the generator and motor electric devices, and changing the magnetic field is based mainly used in the transformer. In our day-to-day life we are getting the power where means from the transformer. No, the transformer based on the changing the magnetic field and changing the area of the coil only few applications. So now we are going to discuss changing the magnetic field. That means if you change the magnetic field, how the induced EMF is produced. So what is our topic? Changing the magnetic field to produce induced EMF. We have to change what we have to change? Magnetic field. It all based on the Faraday's laws of electromagnetic induction. We already discussed very detailed Faraday's laws of electromagnetic induction. If we change the magnetic flux linked with the closed circuit, what happened? They produced induced EMF. The magnitude of the induced EMF we can write the mathematical equation. See that induced EMF equal to what is that? D pi B by dt minus d pi by dt. Here the magnetic flux here in this equation, what is pi b means? It is nothing but magnetic flux. Magnetic flux already we have discussed, isn't it? So B A cos theta. What is that? B A cos theta. Here what indicates B means magnetic field, A indicates area of the coil, and theta indicates orientation. Just now we have discussed. No, we have to change magnetic induction, we have to change the area of the coil, and we have to change the orientation of the coil. What we have to produce? Induced EMF. So we can use this equation. We can prove that how to change the magnetic field. We have to produce induced EMF. Consider this is equation number 1 and equation number 2. Substitute equation 2 in equation 1. So substitute, what will get? The induced EMF equal to minus d by dt. Here negative sign indicates the direction of current. So minus d by dt. Rest of the term pi b, instead of pi b what we have to substitute? B A cos theta. Isn't it? Here see our topic. What is the topic? Changing the magnetic field. What is that? Changing the magnetic field. So here magnetic field represented by the symbol B. Isn't it? See, I circle that. And rest of the term area and orientation of the coil is constant. So how to keep that? So what are the terms are constant? Magnetic induction, area of the coil and orientation of the coil are constant. Which one is to be changed? Magnetic induction dB by dt. What is that? dB by dt. What is the meaning of dB by dt? Rate of change of magnetic flux or field. So we have to change this. Actually changing factor. dB by dt means rate of change of magnetic flux or field with respect to time. When we change, how to change? We have to increase the magnetic power. How to increase the magnetic power? We have to use the power of the mass. So suppose I have taken a simple 2 bar magnets. See that? North and south pole. North and south pole. See this power of the magnet, for example. We have to say 10 Tesla. We have to increase the power of the magnet here. North pole, south pole. So now here, this what is the power means? 100 Tesla. Or 10 Weber here or 100 Weber. Okay. So 10 Tesla is, we have to increase the 100 Tesla means change the magnetic field. No, due to change the magnetic field, the magnetic flux also change. Due to the change in magnetic flux, according to Faraday's laws of electromagnetic induction, they produced what they produced? Induced EMF. That induced EMF represented by this equation. See, I showed that equation number 3 is that final equation of changing the magnetic field. We are getting the induced EMF equal to minus A cos theta dB by dt. This equation is very important. They will give that change in magnetic value or magnetic field value to find the induced EMF. They will give the area value and the orientation value. So next we will go to second one, change in the area of the coil. That is our another method. No. So methods for induced EMF, producing induced EMF, we are discussing one method. Second method, what is that second method? Change in the area of coil. Change in the area of the coil. What we have to change? Change in the area of the coil with respect to the magnetic field. So how to change the area of the coil? We are getting producing the induced EMF. We will see that. So already we discussed changing in magnetic induction, producing induced EMF, isn't it? Now we are going to discuss changing the area of the coil to producing induced EMF. So now what I will do means I will take uniform magnetic field. What I will take? Uniform magnetic field. How that uniform magnetic field means? That is perpendicular to the plane of the paper. I show that. See that the cross symbol indicates the magnetic field. How that acting means? Perpendicular. Where means the given plane of the paper. So I will show the diagram. Suppose we have to see the paper means here. This is the paper where the magnetic field enter and comes out. See, B indicates magnetic field. The magnetic field is perpendicular to the paper, or paper is perpendicular to the magnetic field. In the board I showed like that. The cross symbol indicates the magnetic field is how? Perpendicular to the plane of the paper and acting inverse. How they are acting? Inverse. See here? Magnetic field. Now what I will do means I will take a rectangular frame. Rectangular frame. It is nothing but we are considering metallic frame. That rectangular metallic frame we are represented by the name A, B, C, D. What is that rectangular metallic frame? A, B, C, D. Now I will draw that rectangular metallic frame in the uniform magnetic field. I will fix that. See? So I will mark that points A, B, C, D. This is the rectangular frame. What is the rectangular metallic frame? A, B, C, D. Where is the rectangular magnetic frame? In the uniform magnetic field. In the rectangular frame, A, B, C, D is there. No. Here in the side A, B is movable. How that? Movable. Movable means we have to move in the towards the magnetic field. That means left side of the magnetic field. How to move means with certain velocity. That velocity represented by the symbol V. What is that? The velocity represented by the symbol V. So the side area of the rectangular frame is movable. Move with a certain velocity. How to move means towards left of the magnetic field. How I will move? Towards the left of the magnetic field. I will show that new diagram how that will be moved. So I will draw that once again. Uniform magnetic field. See the board? So this is diagram A, consider. This is diagram B. Okay. Now I move that side of one side of the rectangular frame. So this is first diagram without moving. This is not move, that means fixed one. CD is long. When I move that, the side AB, so I consider A dash, B dash. The whole question is what is that? AB. How much velocity it has to move means certain we don't know that the velocity, so that represented by V. The distance is considered to be V into dt with respect to time. With respect to time, that I indicated T into dt. So before moving that rectangular frame towards left, what is the area means? Area of the frame. What is that area of the frame? AB. Area of the rectangular, length into breadth. Next, when you have to move that rectangular frame towards left of the magnetic field, what is the new area? So new area is considered to be A dash, B dash, CD. This is new area, that means changing. So when I move that frame certain distance, what happens is the magnetic field. What is that? The magnetic field going to decreases. So see that here actually before we have to move two magnetic fields are there in the rectangular frame, isn't it? But here when I move that, just only one magnetic field. So the area is decreased. Not only area decreased, the magnetic field also decreases. When the magnetic field decreases, automatically the flux, what flux means? Magnetic flux linked in the rectangular frame also decreases. Magnetic flux, here magnetic flux represented by phi b also decreases. The magnetic field converted into magnetic flux, so magnetic flux phi b also decreases according to Faraday law of electromagnetic induction. Now we have to apply Faraday's laws. According to Faraday law of electromagnetic induction is short form. According to the Faraday law of electromagnetic induction, what happens when the magnetic flux is increases or decreases? That means changing, no? So they producing the what they producing? They producing the induced EMF. How much magnetic flux decreases? You have to first see that. See that the change in magnetic flux d phi b equal to. Already we have discussed the magnetic flux is nothing but BA cos theta. What is that? BA cos theta. Here, that the change in magnetic flux. Here, what is that? Orientation of the coil, magnetic induction, both are constant. So what we are changing? We are changing the area. So changing the magnetic flux is nothing but BA. So here A means area, isn't it? So B into changing area. Here what is the changing area? Changing area is nothing but B into AB, A dash, B dash, CD. So what is A dash, B dash, CD means? Is nothing but L V into dt. Got it? L, what is that? V into dt. Now we have to substitute this changing area L V into dt. Where we have to substitute that? in this place. A dash B dash C. So what we get? D by B equal to B into, instead of what we have to substitute A dash B dash C in the board, L B into dt. So L B into dt. Got it? So B in this equation, I want to change this dt comes with the left side in the denominator. So dt equal, what is that? BLB. What we have changed? Area going to be changed. No, due to area change, what we have to produce? What we are producing? Induced EMF. We already know that EMF equal to d pi b by dt. Now substitute in this d pi by dt. What we have to substitute? We have to substitute in this induced EMF. So induced EMF psi equal to, what is that right hand side? Right side of the equation B and B. Consider this is equation 1. This equation 1 is our required equation. When we change the area, they produced what they produced, induced EMF. This producing induced EMF is also, what is that? Motional EMF. Already we have discussed motional EMF derived by Faraday's law, derived by Lorentz rules. We have derived very detailedly, isn't it? So motional EMF. When we change the area, we have to produce the induced EMF. What is the induced EMF? Psi equal to BLB. Just please note it down, this equation. This is very important equation. Use this equation. They will ask so many 1 mark twisted and created question, JEE, NEET level question also. They will give the magnetic induction and the length of the conductor and the velocity of the conductor to find the induced EMF. We will see that next class what are the problem based on this equation. Okay, got it? So any doubt for this equation? No. I hope you all are understand very well. So if you have any doubt, please ask. So methods for producing induced EMF, we have completed 2 topics. One is changing the magnetic induction. Second one is changing the, what is that? Magnetic area of the coil. Next, third one, changing the orientation of the coil. What is that? Changing the orientation of the coil. So third one, changing the orientation of the coil. So methods for producing induced EMF, third topic. So changing the orientation of the coil with respect to the magnetic field. This is very important topic. Those who are going to study engineering section, this is the basic. Because in our day-to-day life, in our home, we are seeing so many electrical applications. In our day-to-day life, in our home, we are used generator, electric motor, grinder, mixie, fan. Everything is based on this is changing the orientation of the coil with respect to the magnetic field. Actually, in our syllabus, this is very important question. So many times this question is asked in the 5 mark level question. So we are going to discuss now very detailed. So what changing the orientation of the coil with respect to the magnetic field. With respect to the magnetic field, changing the orientation of the coil with respect to the magnetic field. How to change the orientation of the coil to produce the induced EMF? We'll see that. So now I consider one rectangular coil. Rectangular coil. Suppose I am given a rectangular coil A, B, C, D. That rectangular coil is placed in a uniform where you have to keep the rectangular coil uniform magnetic field. How that uniform magnetic field means? That is perpendicular to the plane of the paper. How that perpendicular to the plane of the paper. How that acting? Acting inverse. And the coil starts to rotate anti-clockwise direction in the magnetic field. Coil starts to rotate in anti-clockwise direction. How that rotates? Anti-clockwise direction with angular velocity. I'll show the diagram. Angular velocity. But angular velocity represented by the symbol omega. Linear velocity means angular velocity is nothing but omega. So what I will take? A rectangular coil. What is that rectangular coil? A rectangular coil is nothing but ABCD. How the rectangular coil is rectangular? Rectangular. So where you have to keep that rectangular coil in the uniform magnetic field. How that the magnetic field acting to the plane of the paper? Perpendicular. Inwards or outward traction inwards. When the coil starts to rotate with anti-clockwise direction. What speed? With the angular velocity. They are represented by here angular velocity. See that? I will take the coil, rectangular coil. See here. This is top view. I'll show that front view. This is actually top view. This is top view only in our book. They gave the diagram. So see that. What is this? The rectangular plane A, B, C, D. Where that kept uniform magnetic field. What is that? Uniform magnetic field. I will show that this is 2-dimensional diagram. I will show 3-dimensional diagram also. What this line indicates? These lines are indicates uniform magnetic field. Suppose this is top view, we call it as plan. What is that? Plan. Plan means top view. It is not in our book. Just remember, sure, give you the idea. Plan means top view. If you see that above that magnetic field. Suppose if you want to see that bottom view or screen view, see that the frame, rectangular frame is nothing but see like that. The number of the frame has n number of turns. The magnetic field is perpendicular. I show you the magnetic field. Already in our previous classes, we have discussed the uniform magnetic field acting perpendicular to the plane of the paper. We can indicate how to indicate means we are indicating the cross symbol. Next, here when the coil rotates. The axis of rotation with the angular velocity. How that rotate? With the angular velocity, anti-clockwise direction, axis of rotation. Angular velocity represented by omega. Okay, this is our book diagram. Book they give the diagram. Actually, not in the sides. That means they are not mentioned in the A, B, C. They are mentioned only this diagram. So here, the area of the coil is represented by. See that the yellow color line. This is what is that area of the coil, and the white color line all are represented by magnetic field. Now the area of the coil and the magnetic fields are all that parallel to each other. Only the coil. What is that? Coil ABCD is perpendicular for the, what is that? Given magnetic field. Because area of the coil and magnetic fields are constant. Because you are changing the orientation of the coil. The topic is changing the orientation of the coil to produce what we have to produce. Induced EMF produced. So, before we are going to discuss, when the coil not rotate. What is that? When the coil is not rotate. At the time we are considered to be at time T equal to, they are not start to rotate. What is that? 0. The coil, how that means perpendicular to the magnetic field. At what time the coil, when the time equal to 0, they produced maximum EMF, means your sine curve, see that? I draw the sine curve. This is sine curve, this is the maximum position, isn't it? The other side maximum position. So sine 90 gets what you know, sine 90 equal to sine 90 equal to 1. Now the coil starts to rotate. At time, we don't know that time. Suppose at about 1 second, 2 seconds, we don't know that. How they rotate in anti-clockwise direction. So it rotates time t second. So it rotates at an angle, isn't it? So the angle is considered to be theta. Here theta is considered to be omega t. What is omega means? Angular velocity. What is t means? T is nothing but time. Got it? T is nothing but time. When the coil starts to rotate initially, how to rotate means it move to in the 360 degree. See, I will show that. In a circle means 360 degree. No, actually the circle is divided into 4 sections: 0, 90, 180, 270. What is that? 360 degree. When the coil initially at 0 in the position, when the coil starts to rotate in the certain time, due to the time the coil moves how much means 90 degree. Next, after certain time the coil moves to 180 degree, and the coil rotates to move 270 degree, and coil starts to move 360 degree. If continuously changing the orientation, that means position of the coil, rectangular coil position change. So due to change in coil, what happened? The magnetic flux also change. Due to magnetic flux change, according to Faraday's laws, EMF is induced. I'll draw another diagram how that coil that changing. See that? I'll draw the uniform magnetic field. See, the white line indicates uniform magnetic field. This is diagram A and this is diagram B. The coil next, the axis of rotation, and next when the coil in the area, see the diagram, area of the coil and magnetic fields are, how that means in the same parallel to each other. But here the coil gets, after some time t second, the coil is deflected. How much deflected after finding? See that the deflected angle theta. What is theta? Theta is nothing but omega t. Am I correct? So there are two positions of the coil. One is position cross position, another one is sine position. See that position 1. This is position 1. Pi m cos omega t. Next, suppose you have to see in the book the diagram pi m sin omega t. What is that? Cos omega t, sin omega t. This is the angle theta. What is that? Theta. The angle theta, the angle between magnetic field and area of the coil. What is that? Magnetic field. Your magnetic field represented by C. I show that the magnetic field B. And area of the coil, this is the area of the coil, that pink line indicates the area of the coil. In between that, the how much angle has to be rotated? See, 0. It starts to certain time, it moves certain angle. How much angle? How much degree they are rotated? Moved in the 90 degree. So here also deflected, the coil deflected, change the position. When change the position, what happened? The magnetic flux also changed. Due to change in magnetic flux, we have to apply the what rule or what law? Faraday's laws of electromagnetic induction. They produced induced EMF, isn't it? So the magnitude of the induced EMF equal to minus d pi b by dt. We already derived a number of times this equation. Just recall this equation. And what is here pi b? Here pi b is nothing but BA. What is that? Cos theta. Here theta is nothing but what is that theta? Omega t. Substitute this theta instead of theta. We have to substitute. What do you have to substitute? We have to substitute omega t. So what will get? Pi b equal to BA cos omega t. Why I didn't change anything about see I showed an example. Magnetic induction and area of the coils are constant. How that? Constant. They are not changing. Only the position of the coil, that means rectangular coil, is going to change. So substitute. Consider this is equation 1. And this is equation number 2. Substitute equation 2 in 1. Substitute equation 2. Where I got substitute equation 1. See what I will get. The induced EMF equal to minus d by dt. Instead of pi b, what I want to substitute? B a cos omega t. What is that? BA cos omega t. For this equation, what are the terms are constant? Magnetic field and area of the coils are constant. So BA minus, so differentiate d by dt of cos omega t. So in the mathematical rule we have to apply the differentiation of cos omega t minus sin. Then we have and omega t with respect to omega is differentiate with respect to time. So what we have to get? Minus BA cos, differentiation of cos is nothing but minus sin omega t into omega t is there. That omega t also we have to differentiate with respect to time. So we are getting omega. So see that minus into minus plus. So first I have to write that B A omega, remaining rest of the term what is that? Sin omega t. Is that sin omega t? Suppose we are considering initially the coil has only one term. In case the coil consists of number of terms, we don't know how many number of terms. See, I want to draw that number of terms. The coil has only n number of terms. It goes on n number of turns. We don't know that how many number of turns. That's why I show that n number of turns. I want to multiply the induced EMF having the n number of turns. Here n indicating, what is that n indicating? So suddenly don't think that how that n came in the equation directly. Actually not directly. We are initially we have to assume only one turn, but it has a number of turns because due to the number of turns only they are producing more EMF. So the required equation n b a omega sin omega t. So we are consider equation number 2. This is equation number 3. See that equation number 3. Just you have to identify this equation. It is the bottom of the board. I hope you are able to catch that equation. Psi equal to n b a. This is not W. It is nothing but what is that? Omega. Omega means what is that? Angular velocity n b a omega sin omega t. Sin omega t. Next, in this equation number 3, I want to give certain changes. What are these changes? See that? From equation number 3, once again, right? So, what is the equation number 3? N B A omega sin omega t. Here, it is called maximum EMF. What is that? Maximum EMF equal to, what is that means? NBA omega. So maximum EMF represented by psi psi m is equal to nb. So instead of nba omega, I want to substitute psi m in this equation number 4. So equation number 4 is nothing but equation number 3 as it is. But in the equation, I consider another equation. So I did equation number 4. In that equation number 4, what is the term? That terms, number of terms, magnetic induction, area of the coil, angular velocity is nothing but what is that? Maximum EMF. So maximum EMF sine omega t. This is equation number 5. Actually, the equation number 5 is our required final equation. Use the final equation. We want to find the different deflected portion of the coil. How much EMF is induced? Okay, got it. How much induced EMF in each position, each deflected position, how much EMF induced in the circuit coil. We have to discuss. First, I will draw the diagram. See that? South pole, and the magnetic fields are, see, the color line indicates magnetic fields, and EMF induced, draw the graph. You have to draw the diagram very careful. The EMF inducing. So the coil has 5 positions. See the board? Am I correct? 1, 2, 3, 4, 5. So first, how the coils are located means in anti-clockwise direction. See, I'll show that. The coil rotates with respect to the magnetic field in the anti-clockwise direction. Each coil has the same area. What is the area? Maybe the diagram indicates the size of the diagram to vary, but actually the area of the coil magnetic fields are constant. So A, B, C, D, D, C, B, A, B, C, D, D, C, B, A, B, C, D. 5 positions. So first position, how that means it's first position of the coil. So first position, how that means the coil A, B, C, D. How that means parallel. This is the symbol of parallel to the magnetic field. How that? Parallel to the magnetic field. When the coil ABCD is parallel to the magnetic field. Parallel means, see, they produce in the induced in parallel or perpendicular, they changes the magnetic area, no. So initially the coil is parallel, so omega t angular velocity equal to 0 degree. So what is our required equation? Equation number 5 is the final equation. Use this equation, psi equal to psi m induced EMF sin omega t. In that sin omega t, see that what is that omega t? Omega t is nothing but 0 degree. Because coil is at what position? Parallel position initially. So what is the maximum EMF produced? Into 0. What is the reason sin omega t 0 means? Because sin omega t 0. Sin 0 degree matter trigonometric 0. So substitute sin 0 degree. What is that sin 0 degree? 0. So psi m into 0. What will get? We are getting 0. Maximum into 0. 0. So psi m maximum induced EMF in the position where the coil is parallel to the magnetic field, the maximum induced EMF is to be 0. That means there is no maximum induced EMF produced because the coil is at what position? Parallel to the magnetic field. Next, you see that second question. This is first one, second question, third question, fourth question, fifth question. After some time, the coil starts to furtherly anti-clockwise direction. What is the deflected angle means? Here the second question. See that the coil A, B, C, D is the coil now. At what position? In the first one, parallel position. See, I will show that parallel position. Here, the symbol perpendicular. The words we have the symbol perpendicular to the. What is that? Magnetic field B. I can't write that. It's then. So the coil A, B, C, D perpendicular to the magnetic field. Here, perpendicular means 90 degree. That means coil is perpendicular to the magnetic field. Coil is 90 degree with respect to the magnetic field. Now substitute that omega t after some time that the angle deflected 90 degree or what is that? Pi by 2. What is that? Or pi by 2. See, I'll show that this is 0 degree. This is pi by 2. What will come here? Pi. What is this? 3 pi by 2. What is this? 2 pi. That means 0 degree, 90 degree, 180 degree, 270 degree. What is this? 360 degree. At any formation, you will be able to understand the values, the induced EMF. Now substitute this equation number 5. What is the equation? The maximum induced EMF psi m sin omega t. What is the sin omega t? See this sin omega t is nothing but 90 degrees. Now substitute the induced EMF psi m sin 90. The trigonometric ratio of sin 90 degree. What is the sin 90 degree? Sin 90 degree 1. So substitute the induced EMF maximum EMF sin 90 value 1. 1 into anything the same value. So the induced EMF produced. This is equation number 6. Equation number 7. If you are getting out of equation 6 and equation 7, when the coil is rotated certain angle with respect to time, how much angle? 90 degree. Initially the coil is 0 degree without starting time. So when the coil further rotated in third position, the coil, what is that coil? The coil is considered to be A, B, C, D. How that? Again, once again, see the diagram. The coil is parallel. See the third position of the coil in the magnetic. How that? Parallel to the magnetic field. How that? Parallel to the magnetic field. The coil is parallel to the magnetic field. If parallel to the magnetic field, but the coil is continuously rotated in anti-clockwise direction, as in the second position 90 degree means third position what is that? It moved another 90 degree. So that theta omega t is nothing but 180 degree or pi. What is that? Pi. When can use that induced equation, EMF equation, sin omega t. What is omega t? See that omega t is nothing but 180 degree. So sin 180 degree r pi. So here also we can write that r pi by 2. So we know that sin 180 degree is nothing but 0. Sin 180 degree is nothing but 0. So what is the maximum induced EMF? So into 0. So we are getting 0. They are not producing any induced EMF in the third question. Next, fourth question. The coil further rotated in the anti-clockwise direction. The coil ABCD perpendicular. What is that? Third question is parallel. Fourth question is what is that? Perpendicular to the magnetic field B. So what is that angle? The deflected angle omega t equal to 270 degree or 3 pi by 2. 3 pi by 2. So substitute that the induced EMF, maximum EMF into sin omega t. What is sin omega t? 270 degree. So maximum induced EMF sin 270 degree or 3 pi by 2. What we get? So sin equal to maximum into sin 270. The trigonometric ratio, if you see that, -1. What is that? -1. What is the reason? Sin 270 degree equal to -1. That means maximum induced in the opposite direction. Maximum induced in the opposite direction. So there is this one. So what is the final equation we will get? So induced EMF equal to maximum induced EMF into -1. So the induced EMF produced in the opposite direction. See that? This is 270. No, this is the maximum point. So induced EMF produced in the opposite direction. Negative induced EMF. And coil is further rotated completely in 360 degree. So it rotate further anti-clockwise direction. Move the 360 degree. That means the coil ABCD. Once again, if comes into the starting position, it is parallel to the magnetic field. Parallel to the magnetic. What is the induced EMF? Here, the deflected angle 360 degree or 2 pi. Sin 360 degree is nothing but 0. Sin 360 degree is nothing but 0. So what is the equation? Required equation? Induced EMF. Here sin omega t. Here omega t is what is that? 360 degree or 2 pi. See that sin 360 degree, what is that? 0. Substitute 0 in 360 degree. Sin 360 0. So sin 360 value 0. So into 0. So 0 into anything 0. So the induced EMF produced in the fifth question is 0. That means last equation is 7. This equation 8. Reflected question, coil question number 3 is equation 8, and coil question 4, equation number 9, and coil question 5, equation number 10. This is the 5 position. The coil is deflected. Due to the deflected, each position the magnetic flux linked in the coil changes. Due to changes, they produce in the magnetic induced EMF. How the magnetic induced EMF produced? Due to change in the orientation of the coil. This is very important question. So you have to prepare as it is in your book, and also I hope that this diagram not in your book. Another diagram is there. It is nothing but the same diagram. So you have to draw number of times in this diagram. Then only you will get a correct diagram in the examination. And this part is very important. So each position, when the magnetic field is parallel to the coil, means they are not producing any induced EMF. That means the magnetic flux is not linked to the coil. When the coil is perpendicular to the magnetic field, that time the magnetic flux is linked and changed, they producing the induced. I showed that. Any doubt in this question, please ask me. Okay, thank you.